And now we have our final session before lunch to talk about the foundational models and the operationalization of GeoAI. And to lead the panel is T. Barr. T?
I love batting cleanup before lunch. And please ask questions, otherwise let's go into hard podcast mode and just talk to these people, and we want to talk to everybody today. But please, go ahead and introduce yourselves.
Okay, that was abrupt. Anyway, I'm Sourav Mazumder. I'm from IBM. I'm a kind of a generalist AI person, working with various clients of IBM to help them use AI, adopt AI. My foray with the geospatial is just maybe last 2-3 years. While doing the general AI, I started realizing that, okay, it really does not have anything grounded. But he was also saying, the main thing what I realized that, okay, bringing in the geospatial concept in the regular AI, whether it is text-based or image-based, really help it to move forward. And that is the reason I started learning the geospatial more and more. Today I was seeing Chris's graph there that, okay, your confidence and then it going down. So mine is a little bit oscillating. When I came here, it was at the top after hearing all these sessions. So far, it is kind of here. So I'll just share whatever I can.
Hi, I'm Briana Brown. I lead product and marketing at Acopia AI. Basically, what that means is I help figure out how to package up the data that we produce and talk about it. If you're not familiar with Acopia, we are a data provider. We do not provide software. We don't fly imagery. We just provide vector data, sometimes some rasters, but never imagery. And the way that we do that, we are GeoAI through and through. So we've been doing GeoAI since before we called it GeoAI as an industry, since 2013. Our whole business was founded with the idea of what if we could speed up the bottleneck of taking all of this imagery that we collect every single day and vectorizing it into shapefiles that people actually want to work with in their traditional GIS. So really at its core, what our product is data that we have used an AI to extract from imagery. And while we started as a custom feature extraction business, over the last few years, we have, here's some of our data, I think, playing behind me. We have transformed into an off-the-shelf data provider. So, we have off-the-shelf land cover, 2D, 3D, transportation features, all of that available throughout North America, various countries around the world, and we do still have our custom feature extraction business as well. But yeah, I'm excited to talk with you folks about foundational models today.
Great, good to see everyone. I'm Peter Wilczynski. I run the product team at Vantor, rebranded Maxar, rebranded Digital Globe. We're known for high-resolution satellite imagery, and increasingly the focus of the company is really building towards a self-driving TC-PED system, right? And when I think about AI, I think it's easy to work forward from the technology, but I think the focus we have at Vantor right now is really working back from operations. Like, what do people do, and how do you automate that end to end? I think there's been a lot of skittishness about this, but that is sort of the end state that I see for a lot of AI-driven companies, really self-driving companies, companies where the vast majority of the people at the company are focused on developing software-defined rules and engines that prosecute those rules, and the company itself really becomes a code base. And I think when you look at companies that have truly adopted AI, companies like a Google, like a Jane Street, prop trading companies, ad tech companies, everyone could leave and the company would keep running because the company really is a software program. And I think the exciting moment we're in right now is that the future of every organization, I like to say every program will become a program, right? We're in this weird period for 50 years, program has had two definitions. It's sort of a government program, a development program, it's a thing that humans do. And then in the 40s and 50s, we adopted that word for a thing that computers do. And I think the future is that every one of these programs, every one of these things that civilization does will become a software program, right? And so you'll see this conversion from law to code, and that will become sort of the fundamental substrate of the world. And I think part of what makes this possible, part of what makes this grounded, is grounding these programs in a fundamental understanding of the physical world, right? Digitizing that physical world and then making it computable, making it programmable.
Excellent. So diving in to frame the conversation, when I say GeoAI foundational models, what does that mean to each of you? Like, is it something deeper? How does the Earth work? Or is it just standing on the shoulders of giants?
Well, for us at Ecopia, so again, our whole business is digitizing imagery into vectors. So when we think about a foundational model, it's how do we train a machine to think and interpret imagery like a human would. So as geographers, I'm sure we've all spent too many hours manually, painstakingly digitizing features from imagery, but we all have a thought process going on as we're doing that. Sometimes it's pretty straightforward. Okay, here's the building. I can, create vertices and it's done, there it is. But then other times you're looking at a sidewalk and maybe there's some tree canopy that is obscuring part of the sidewalk, but we as humans, we know, okay, the sidewalk is clearly continued underneath it because you can see it on the other side. So creating a foundational model that can think the way a human does and create a more standardized data set at scale. Because the whole idea of AI, the whole reason why everybody is really excited about AI is the scale and the leverage that it brings us in any industry, but especially in geospatial. And so a foundational model that can scale and standardize, but still have that local nuance, those interpretations that a human would have, that's how we think about it. How do we start with one feature, but then also adapt the AI to be able to extract across diverse geographies, across different features that might be available in one geography versus another. For example, grass is different colors in different parts of the world. So how do you train the AI to say, yeah, this is still grass, and in the data schema, it should still be grass, even though it's brown here and it's green here. Generally, when we're thinking about it within the lens of our business, that's how we think of our foundational model.
Yeah, I think about models, really, there are two kinds. There are data models and logic models, right? Nouns and verbs. And if you think about sort of building a complicated system, you're taking data models, applying logic models, and out the other side comes another data model. So, in geography, fundamentally, you have a digital terrain model, you have a digital surface model. These aren't necessarily conventionally considered foundation models in the way we're talking about in the modern vernacular of sort of AI, large language models. But I think it's actually really, really important to think about, when we're talking about a field that's moving really, really quickly, the language is really, really imprecise, right? That's sort of like Kuhn's key observation is like you're in a paradigm shift when the words are ill-defined. Like once the definitions are solid, then you're done. We know what we're talking about, we know how to reason, we can talk with language about the concepts that have been developed, but we're in a period of extreme paradigmatic uncertainty, right? There are so many anomalies. There are all these models now that can do things that didn't exist a year ago, didn't exist 6 months ago. And so, I think, for me, I actually try not to define foundation model because I think it's a little premature. I try to stay very specific with particular models, particular instances that have been developed, rather than trying to go to the class level and the categorization level. I think, it's much more productive to look at the world model from World Labs, or, the large geospatial model from Niantic, or the remote sensing foundation model from Google, the Bedrock model. These are very specific models that do very specific things. And I don't think we're at a part, when you think about a category defining company, what that does is it literally defines the category, right? Like Salesforce defined customer relationship management, CRM. It didn't exist before then. And so I think we're a little bit early to be trying to apply a taxonomy or apply classes to things that are actually moving so quickly that haven't consolidated down.
In our world, like in IBM's world, so before getting into the geospatial foundation model, let me try to say that what is the foundation model in general. Foundation model is, as Peter was saying, it is a kind of an all-purpose model, right? You built it once with a large volume of data set, and then with some extra knowledge, imparting some extra knowledge, extra context, you can actually fine-tune it to do a specific task. In the geospatial world, the way we see the analogy is that think of it's a geography scholar who knows many things about what is happening at the world level, geography level, and give that person a context, and that person can give you some answer. So that is the way we are trying to build foundation model for geospatial in IBM. I think we just released a few months back. It is called TerraMind. That foundation model is built with 9 different kind of data sets, starting from satellite, radar, text data, contextual data, getting the data from European Space Agency, Kepler Lab, Zulich Institute, German Aeronautics. I mean, 5 or 6 different bodies. They came with the open data set to really create that foundation model. And that foundation model can be further used for multiple different tasks. One is surely identify different kind of Earth observation, whether to figure out land cover, whether to figure out, you probably were seeing some of the picture there, to figure out a tiny elephant at a bigger scale in a pasture from the satellite imagery. You can also use it for, say, climate downscaling. Say there is a climate physics-based climate model which is run for something at a not that high resolution, maybe at the 100 kilometer level. Now you want to downscale it to 1 kilometer by 1 kilometer level. You can use this foundation model. You can fine-tune it. So that is the way we are seeing in the IBM that the geospatial foundation model should happen.
Okay, thank you. Let's get into the deep end now. Over the past couple of weeks, you can't pick up an economist, a Financial Times, or anything without hearing about the AI bubble. As we operationalize GeoAI, there has to be an ROI to that. Do you see there being a GeoAI bubble, or you see a capability to get an ROI with the GeoAI? Because I know, Peter, you guys put hardware in space. That's not cheap. And you have to process all the imagery. Are you going to be able to recoup those investments or not?
Yeah, it turns out it's a lot cheaper than building data centers. But no, I mean, I think this is the $100 trillion question, depending on who you talk to, maybe just $1 trillion. But I don't think anyone knows, right? I think the fundamental thing in economics is costs are really legible and value is really illegible. And so, markets are always trying to match capital to generate something that has a value higher than the cost. That's like the basic principle of building a business, building anything really in a capitalist system. And I think that the challenge is the costs here are really, really high. And I think the question is sort of what do you do with the costs and how you generate value? The two obvious things are you build new things or you build the same things cheaper, right? Those are sort of the fundamental things you can do to generate value. And I think a lot of the focus has been building the same things cheaper, right? It's always been an efficiency play, and you hear people talking about automation of labor and getting rid of jobs and replacing jobs with AI. But when you look at businesses, like that doesn't get you. It doesn't actually pencil, right? Even if you automated all of the labor, you probably don't create this step change in the economy, right? We need to build new things, do new things, and to me, that means moving into robotics and moving into sort of physical intelligence, which fundamentally is going to be grounded in spatial intelligence, right? You need to actually move atoms in the real world, convert watts into movement, and actually, really think about reshaping the physical world in ways that, are pretty foreign to us in the West, but perhaps, a little bit more common in the 40s, the 30s, when we built the Hoover Dam, when we built, all of these massive infrastructure projects, right? That, to me, that's where the ROI on a lot of this is going to come from. And if it stays digital, I think you can get a lot of efficiency. You might get some new digital products, but I think it is a pretty sad state of affairs when the first product that the Meta Superintelligence Lab released is an AI-generated video slop feed. That's exactly what we already have, just built cheaper. And I don't think that that materially helps the economy grow. So again, I think it's harder because it's a little less observable what's going to be different than today. But yeah, I think today a lot of the application is in efficiency. And I think if all we get is a lot of efficiency, it's not going to pencil.
Yeah, I also think there's two different ways to think about ROI. There's the ROI of, all of us that work at companies that are creating these new tools and products. So, what's our ROI and all the R&D that we're doing? Is this going to be the bet that, changes the trajectory of our company? On that side of things, I think, there's a little bit too much of this, like, what we call competition, I guess, so every company that's present here today and also in the industry, we're all specialists at something, and we all say that we work together, but then at the end of the day, we also try to rebuild everybody's solutions all the time. And so that actually hurts everybody's ROI in the end, because if we all were to just really focus on our one niche and truly partner together, and Vantor and Ecopia are partners. Clearly, you see the logos everywhere on these slides, because we apply their sensor fusion technology with the imagery to our vectors so that they don't change over time, things like that, or they don't change location over time and drift. So, my point is, though, we need to make sure we stay in our lanes and don't just keep reinventing this GeoAI wheel. So I think that's one part of the ROI from the business side of things as we all decide what to invest in. The other side is the ROI that our end users get from our products. So, are we building something that's just cool and flashy? And I mean, there can be some value in that, right? Like gamification of certain things and video games and all of that. But then also from a GIS practitioner standpoint, are we building a tool? Are we building something that is actually going to move the needle in their productivity, in their ROI? If you're thinking about, the salary or the hourly wage that they have and what they might have spent on something before using AI versus after, that's a really important consideration. Just because you can build something that is AI based, should you, or is it actually going to move the needle for the end user?
Yeah, I kind of agree with both of them. Again, AI can help in operations. Either you think of AI can help in doing low-cost automation, or think of this way, AI is essentially for every business. For a business, maybe it is creating 1,000 extra workers without the business paying for them. Or they're paying it, but different way. So it is primarily right now to address the operational efficiency. The business, they need to think really differently how to use AI to generate more business stream, different kind of products, different kind of avenues. Now, when it comes about the geospatial, again, it is even much more complicated to think that what kind of extra business revenue or business channel it can create. Maybe at the spatial level, some of the pharmaceuticals, they are thinking of molecule discovery for the new kind of products that is happening. That is surely helpful. At the geospatial level, really there is nothing much to help the business to further grow, at least as of now.
Excellent. Of course, we still have to deal with the perception of the AI bubble as we move forward with all this. And this is going to be a very interesting 2026. Anyway, going ahead. So what do you feel are the missing ingredients to a full planet, assuming we discover that we can make money off this? What do you see what's missing right now from a full planetary model and us being able to build a GeoAI that's basically a digital twin of the entire Earth and all of our systems?
In my mind, it is still data. We still don't have enough data available to build a real geospatial foundation model at the planetary level because of various reasons. Obviously, the data privacy is the one reason. Another reason is all the political boundary, right? GDPR. And there were, I believe, all different kind of policymakers, they can come together to help building that really planetary scale geospatial model. The common idea is that, okay, if I'm giving the data to a model, I'm giving some very specific information, but in reality, model really does not go for specific information, right? It kind of try to extract out the latent information from all the data, and then use that to create some pattern, and then later on use that pattern to identify something, predict something. So technologically, it is possible to really hide the specific information coming from different data sets, but I think still all the various bodies, they need to come together to decide and see what all geo-level data can be really made available for big planetary model. Like for the IBM's case, when we built TerraMind, at least 4 or 5 different organizations in Europe, they came together to give us the data to build such a model.
I agree, and we create so much data as an industry. I think that's been echoed in every talk in some way throughout this conference. But most of it doesn't talk to each other. So interoperability is the way, the real world is interoperable, like more or less, like everything is connected in some way. But our data does not reflect that. So whether it's through, unique identifiers for addresses or, POIs or, certain hexagons, all these things, like there are multiple unique identifiers that everybody uses, and some talk to each other, some don't. Like it's everything is kind of a mess. Like clearly we understand the mechanism to make something interoperable, but we're not applying it in the right way. So to really make a true planetary model and to mimic what real life is like, where everything is interconnected, we need to make sense of our data within that regard. There's just so much data out there. Many organizations just feel inundated with it. Another aspect of this is actually we've been seeing a lot of, I shouldn't say a lot, I would say a decent amount of our clients come to us and say like, hey, this data is amazing, but there's so much of it. One, like my computer keeps crashing. And 2, how do I sift through it and like really leverage it to its full potential? So I think there's like a training aspect of it too. And, I don't know, it's been a while since I've been in school, so maybe this has been better applied in curriculum, but so much has changed in the past decade that it's like there's so much more data out there that people also need to know how to work with that data and take advantage of it.
Yeah, to me, it's fundamentally about demand. Everyone at this conference is focused on supply, right? We're focused on building maps, but economics, like the winners in the market, right? ChatGPT is not GPT-4. There's a real product that's powered by a model underneath it. Google Maps is not a remote sensing foundation model. It's a real product that's powered by a ton of AI. And so I think when you think about sort of what does it take to build a full end-to-end, digital globe system, I would claim we have 2 or 3 of them in the world. Google has one, Apple has one, and when you look at the budget, it takes about $400 million a year plus about 3,000 software engineers a year. That's rough, like not $400 million of data and acquisition and compute costs, plus the salaries for 3,000 to 4,000 software engineers at the top of the level. And so that's expensive. I think that's a really expensive thing to produce, and there's only a couple of them. And so I think our focus at Vantor, I think the focus of all of us on the supply side, it has to be driving the cost down so that more people can produce that quality of map. Because I think fundamentally that cost creates a huge barrier to entry for other people, right? Because the bar is set at Google Maps. If you are building a product and it's not as good as Google Maps, it's not as good as Apple Maps, you are not going to get adoption because the customer expects that. That's the new baseline for the quality of a mapping product. And I'm sure we all have our critiques of Google Maps and our critiques of Apple Maps, but the reality is they bring together a ton of data into an end-to-end product. And so I think the thing that is fundamentally missing is demand. And that's why I'm so bullish on robotics and sort of the push towards physical intelligence, right? I think things like Waymo, things like Zoox, things like the Optimus robot, things like the physical intelligence systems, like that is going to create demand, and it's not coincidental that Google owns Waymo. Like that's not just an accident of history. Like the fact that they had Google Maps fundamentally makes Waymo something that they can go after. And so I think the question economically, and again, you see these big 7 companies are 40% of the total market capitalization of the indexes right now. The big question is sort of like, A, what are they going to do, right? And how are they going to compete with one another? Are they going to enter each other's markets? And then how do they bring the rest of the industry around so that they're able to do so at an effective cost point? And when I think about at least our business, I think a lot about TSMC, where TSMC has developed a Switzerland business model where they build the fabs and they drive the cost of producing chips down such that even the biggest companies in the world would never finance their own fabrication units. You would go to TSMC with your design and then you would get a chip out the other side. And so I think as an industry, we have to really think about how do we create that sort of capital intensive part of the industry that's cheaper, right? Fundamentally, it has to be cheaper. And the only way to make something cheaper is to amortize the cost of production over a lot of customers. You either have to do cost plus, or you have to take the cost and amortize over a bunch of customers. And so I think, to me, the thing that's missing in a lot of these conversations is the demand side, right? Like, where are the dollars going to come from?
Okay. Shifting gears to ethics, or trust, as we would. Sourav, when GeoAI starts influence our finance, defense networks, and other things, how can we ensure that we can still trust the AI moving forward?
Yeah, so trust is surely a big thing in AI, big question. So let me try to first demystify it. What is really trust for AI or for any person, any business to use AI? One is transparency. I must know where the data and other things are coming from to make that AI. Second is reliability. Does it tell the same thing again and again, the same result? Does it have any bias? Does it forget the context, basically hallucination? So that is the second part, what I will say, that how reliable the model is. And the third is the interpretability. The model should be able to tell that why it is really doing some prediction or some kind of inferencing, some kind of answer. It should be able to tell where from it is getting the data, getting that information, attribution. So these are all things which is going to make a model really useful, trustable. In general, AI or general purpose AI, what we are discussing here, foundation model, they are really not good in that. Transparency, yeah, many of the companies, when they build the product, they tell exactly where from the data is coming, what kind of algorithm is used. Like in IBM, we surely maintain that. Everything we tell as a model facts, that these are the data there. But now when it comes about the reliability, there are different ways one can figure it out, the reliability, but it is all based on the use case. Like for foundation model in the geospatial, the 2 or 3 different use cases what we see, one is detection, object detection, then classification, and third is mode of prediction, like I was saying, the climate prediction or climate downscaling. Now for this type of use cases, it is kind of still relatively easy to see what is the accuracy of the model, and one can create a system, a validation system, before releasing any model to ensure that I know the operating range of the model. So what happens once you know the operating range of the model, whenever a new question comes to the model, new image for identification, you kind of figure it out at which zone it is operating, and even you can create a guardrail system to say that, okay, that this information is this much reliable by 60% or 70% or whatever. So it is still possible for geospatial. I mean, that way it is better compared to the regular text model. Regular text model is very difficult because there is no right answer or wrong answer. So geospatial-wise, at least for these use cases, we are good to have some trust. If you can build a validation system, guardrail system before using the model and also while using the model. The last thing comes the real explainability of the model, where the general purpose models are very bad. I mean, right now there is no real way to explain, or I will say that what regular people can understand whether whatever the model is saying, how it is doing that. There is no proper way. On the attribution, yes, it is possible. Many models are trained in such a way that you can actually attribute it where from the image is coming. At least all the IBM models are trained that way. So overall, in my mind, trust is a very important part. And it is important, whoever is building a model or using a model, at least you know how the model is built, and while using, know what could be the potential pitfalls, and accordingly have some guardrails inbuilt.
So dovetailing into that for the group, so how do you see humans in the loop then? What's our role in of maintaining trust with AI and keep moving forward?
Yeah, I will take a stab there first. So it is a huge role of the human in the loop. And the more we are moving towards this general purpose model, again, this foundation model concept, all the regulations are also demanding it. So the way I see these foundation models would be evolving, it is like you should, or one should treat a model as my co-worker, maybe less experienced co-worker who is helping me, and I should be able to validate each and everything produced by the model. So accountability still remains with me, not with the model. And the way it is going, most of the regulation bodies are also asking for more and more human in the loop possibilities, or while using the model. It should not be just all black box.
Yeah, I disagree pretty strongly with that. I think you have to ask which loop is the human inside of and which loop isn't the human inside of. But I think fundamentally having the human outside of the loop is important in operations. I think if you're going to build an operational system, the human has to be outside of the loop. And I think, when I think about prop traders as sort of like, hey, what is the end state of many companies? And there are a lot of humans who work for proprietary traders in finance, but they're not executing trades, right? The model is executing trades autonomously. They're developing the model, they're testing the model, they're training the model, they're understanding the performance characteristics of the model, they're A/B testing the model against simulated and adversarial model effects, but ultimately, Knight's Capital went bankrupt when the model underperformed and spiked BMW's price, but the other ones didn't. And I think that there is a fundamental way in which the models are going to be operating autonomously in the world, right? Like Waymo does not have a human in the loop. It's a model that drives a car. You get in the car and it drives you from point A to point B. There are a lot of humans involved. There's a human apparatus, there's a support network, there's humans involved in various parts of the system design, but again, I think it is pretty Pollyannish to imagine that we're going to keep the human in the loop. Like, we don't keep the human in the loop in a lot of factories. We don't keep the human in the loop in a lot of fly-by-wire piloting systems. Like, there are already a lot of systems that don't have humans in the loop. And so I think you have to sort of define which loop is the human inside of, or on top of, or unrelated to. But I think that the future is going to be models operating independently. And I even think going back 400, 500 years, right? Like, a fundamental innovation of our society is limited liability corporations, right? That was fundamentally taking the human out of the liability loop. And it allowed us to organize in much more effective ways. It allowed us to take risks that otherwise would have been catastrophic, put people in jail. And I think people can have critiques of specific limited liability corporations, but the idea of a limited liability corporation is fundamental to the way we organize society today, right? It's about limiting the liability. And I think it's, again, there are going to be bad things that happen, but we have to be a society willing to take risks. We have to be a society that is not afraid of its own shadow and is not constantly trying to protect ourselves from the possibility of harm and actually omit all of the other opportunities that would have saved tons and tons of lives. You know, running these systems in production will have huge consequences, but you know, I think we can't worry too much about the second and third and fourth order consequences. Like, those will happen, but again, I just don't think that the right decision for society is to just sort of like freeze ourselves in amber and say, hey, we're just going to be the same as we were in the 50s.
Well, an interesting point you bring up is the, you know, I guess the relation to sort of like the Industrial Revolution and like factories, and how today there's many factories that run without humans, but that wasn't the case when factories were first, you know, brought about. And so it's kind of like, okay, where are we in that AI revolution if we're going to compare it to the Industrial Revolution? We're certainly not at the end of it. So I think at this point, yeah, humans definitely need to be in the loop in some way, but that's going to change over time. Whether it's going to be they move to a different loop, they move to a part of the loop, and then that diminishes and diminishes, or you know, something else that we can't even like think of right now and how that relates to the loop. I think that's going to change as AI continues to drive this revolution within geospatial, but within every industry as well. At Ecopia, we tend to see humans, I guess, pre and post loop, if you want to use that term, I don't know. But so, you know, getting end user feedback ahead of time, like if we're doing like a custom extraction, for example, on features that we've never extracted before, we need that, like we need a human to tell us like, hey, extract all golf cart paths that are greater than 5 feet wide. We need that human input into the loop, then say it goes through the loop, and then afterward we need to verify that that is in fact what the model did. And so we tend to say that our data is, you know, AI generated, human verified, because we do have a scalable human verification system on our end for quality control. You know, we don't have somebody sitting there looking at every single vector, but we have a way to kind of automate that across, you know, large scales. So at least that's where I see the human involvement today from the vector creation standpoint, and that's a big part of trust, which we were just talking about. A lot of people, I find, tend to think that adoption of AI is like a 0 or 100. It's not like a scale. There's a lot of people that are just like totally afraid of it, and I'm like, nope, if it's AI generated, it's garbage, like I don't want it. And then there's other people that will just go straight for like, you know, AI only, but then maybe it's not 100% there yet. So there's kind of this happy medium right now, and that's at this point in time how humans come into the loop to complement all of this new innovation.
Let me add one more point to that. I mean, this is really interesting. I mean, very diametrically opposite opinion, and also you're kind of midway. So one thing we need to acknowledge that we are moving from deterministic automation to probabilistic automation. And I totally agree with you that we cannot stop it. I mean, we can feel always like, no, human intervention has to be there. But eventually, I agree with you that that is the goal we are looking for, that how do we as a society accept this probabilistic automation, right? Something may go wrong. But again, coming back to whether we are there in that journey, in my opinion, we are maybe not even at the 10 at the scale of 0 to 100. I mean, we are just seeing it. We are just seeing some kind of automation coming through AI, through agentic AI, right? I mean, what is agent? Agent is just doing some task autonomously. Now, yeah, we all envision that there would be agentic AI where agents are getting spawned in situ. I mean, just autonomously, they are doing some work autonomously. Eventually, the work is getting done, but whether we are ready for that, whether we can have a trusted agent section, my opinion is not. But I agree with you that what should be the vision. The vision is towards that, and it also needs a lot of change in the culture or the skill. Like I'll give you one simple example. Say, self-driving car. I am very sure many of us drive here today. For me, it was a skill I had to learn to delegate that risk to the car that, okay, the car will not make any mistake. So it is also kind of learning for the society, for the people, how to use that kind of autonomous AI. So it's a miles to go.
Yeah, I think it's just productive to think about AI as software. It's just an extension of software. It's an extension of the trajectory we've been on for a long time. And while we haven't had necessarily as stochastic or probabilistic software, we've intuitively thought about software being somewhat deterministic. Like, operations research has been a field of study for 100 years, and that's fundamentally about binding non-deterministic systems within a deterministic system, right? Like, our brains are not deterministic. We do not run deterministic logic inside of our heads, but we've developed systems that can bind non-deterministic reasoning engines inside of deterministic reasoning engines in ways that control the error sufficiently that we're able to build very sophisticated apparatuses. So again, I think we've done that before. Like, a call center today is a ton of software with a ton of people, right? And the people are performing non-deterministic logic. They're performing serialization and deserialization of language. They're performing reasoning. They're performing various empathetic techniques. But fundamentally, you know, there's an orchestration layer which is deterministic, which routes calls to individual people, which, you know, routes your phone to your account on the back end, which maps your account to the transactions you've done recently. And I think, you know, those have been systems that haven't been amenable to software development because software hasn't been, you know, programmable in terms of language before. But really, I just think of this AI generation, the thing that's exciting to people is that the computers can speak natural language. And all of the things that require natural language processing have been out of scope of software. They're now in scope of software. But I think of sort of when you play it forward, it's more just everything becomes software, right? Which, again, was true. Like, if you think about the legal code, that was just software. It's just written rules that humans execute. And I think that, you know, you're going to see a conversion from the legal code to source code, but it's going to have similar structures to the legal code.
So, Mike 1, I appreciate your patience. Go ahead, please ask your question.
Or a statement, which is Alan Leidner. I'm President Emeritus of Gizmo and a former GIO of New York City. And I want to point out an opportunity which really hasn't come up on top of this wonderful GeoAI, which we're all looking forward to, which is you have established bases of enormous amounts of structured data at the municipal level. You're in a city that has one of the best municipal GISs in the whole world. And the opportunity I see, which hasn't been spoken at yet, is that building the GeoAI on top of 1,000 layers of data, municipal data, all registered to a common, highly accurate base map, offers opportunities that haven't even been explored, including all kinds of return on investment, which I could go on in detail. Having been the GIO, I had to prove that to OMB. So I would suggest maybe at next year that we really have a couple of explorations of exactly the foundation that exists in municipalities, in big cities like New York, and what they can do along with the GeoAI to create enormous new powers that just getting satellite data is not going to do.
I totally agree. I mean, I think this is the most emancipatory case, which is, you know, AI right now is a homogenizing technology. It makes everything the same. And I think the opportunity is to take some of the consumer surplus we get and make places different, make them, you know, more unique. And my favorite map in the world is the New York subway map. And I think, the fundamental thing about the New York subway map is it tells a story of New York. It doesn't tell a story of the WGS84 datum, right? Manhattan is much bigger. The outer boroughs are much smaller. The Central Park is much more prominent. And that's opinions that people have brought to bear. And I think we've lost a lot of that as we've gone to much more raster data and being able to sort of unlock a lot of these data feeds that exist within various municipalities, within various organizations. Like, I think that is the emancipatory version of, much more generative cartography, much more interesting maps that look different place by place. Like, I wish that when I got off the plane in New York, the map was not the same as the plane in London, as the map in Paris, as the map in San Francisco. Like, I think having more heterogeneity spatially, it just generates a much more interesting world, and I think there is probably a lot to do there.
I would just like to end with a statement that at this particular point in time, 40 city agencies are actively using the base map and the hundreds and thousands of layers, plus hundreds of applications, all receiving an ROI. And I think using planimetric data, raster data, the whole spectrum of things to make everything work. It would be useful if some of the GeoAI companies would explore that richness to see what the combination of the two could really do.
I think that is, you're totally right, and that's what IBM was trying to do for the Europe. Many times in the US, especially North America now, getting the data and the copyright on the data, that is becoming a problem. That is the reason many companies—
It's all open data.
Even
1,000 layers of open data on the city's data portal.
I know you can use the open data, build the model, but when you are using that model for some other purpose, there are some legal implications.
We should discuss that and
Yep.
see just how we could work together.
Thank you. So we're getting a 1-minute warning. So lightning round, how do you see GeoAI in the year 2050?
Okay, technologically, I see surely the quantum coming together, and it can really help to establish the real multidimensional space, the high-dimensional space that GeoAI is. So that would be my take on the technology front.
I see us having a more robust catalog, I guess, for lack of a better term, a catalog of data sets that are just readily available. Right now it's kind of disparate. There's some data sets are open, some are private. You have to figure out, even if you just want to look at, parcels or something like that, a lot of times you have to piecemeal everything together. So I see with all of this new technology that's coming out, us being able to really standardize data production, have it be interoperable, talk to each other, and having almost this catalog of data that people can more readily access, and it's not behind the wall of a company within their own product. Many of us, Ecopia included, we have our own data catalog, but as an industry, I see us, collaborating a little bit more to make all of this data more interoperable and accessible. So the base map question that just came up, so that things like that can be more possible.
Yeah, this might be offensive, but I think we're going to see the death of the map and the rise of the graph. Increasingly, the first law of geography, that things that are close to each other are similar, is going to be violated. And it's actually going to be things that are far away that are close within some sort of graph structure. And you already see this in supply chain monitoring. You see this in the increase in sort of pointillistic navigation, the way in which place A and place B are connected via multidimensional routing systems, such that people no longer know how to navigate between places and spend their time navigating between points. And so I think you're going to see a much more graph-based representation of the world, where there's going to be projections of an underlying map into purpose-driven graphs that are much more, purpose-oriented, right? So the map is going to be a secondary data representation that grounds a lot of these graphs, but a lot of the sort of operational workflows are going to be, much more graph-centric, right? I always say JFK is closer to SFO than it is to Newark, right? There are no flights from JFK to Newark. And I think when you sort of start thinking in terms of topology more than topography, like that is how a lot of these systems speak natively, like these graph-based models, I think are going to be much more powerful than map-based models. And so I think a lot of the purposes of the map are going to be to ground the graph, but you're going to see places that are very far away from each other much more connected, right? The TSMC fabrication facility in Arizona is much closer to the TSMC fabrication facility in Taiwan than it is to Scottsdale, right? In terms of the people who go there, the things that occur there, the connective links to other things in the world, like that, as we build a more sophisticated economy, like place is sort of a secondary attribute that grounds the system, but it's not necessarily a primary attribute anymore.
Thanks, I appreciate everyone's time and traveling here. And John?
Great. Thank you, T. Briana, Sourav, and Peter.